Graphene is a unique nanoscale form of carbon that is disrupting legacy materials, bringing step-change improvements in performance across a wide range of industrial and consumer applications. From energy storage and electronics to everyday materials, graphene enables products that are better, stronger, and lighter, while increasing durability and improving sustainability. Graphene is leading the era of new advanced materials.
The following is a presentation that was given as part of a two-day virtual Graphene Investors Conference, hosted by the Graphene Council.
So, first of all, Manju Gunawardena from Ceylon Graphene Technologies. Hope everyone knows about the company. We are a Sri Lankan-based company, having different techniques to convert vein graphite into different types, as well as different varieties of graphene and different carbonaceous and graphinated materials. So we started 9 years ago. Now, currently, we operate 2 manufacturing operations in 2 locations. The main factory is in Sri Lanka. We are a Graphene Council certified manufacturer, graphene oxide, functionalized graphene oxide, and different specific or mission specific requirements we fulfill with our plant based in Sri Lanka. So Graphenova is a new addition to the Ceylon Graphene Technologies umbrella. We are based in Australia. So under the mother company, we started a new company in Australia to produce plants for the graphene world. Up to the last year, we were only producing materials to you all, right? If you can go to the other side, Terence. So the company operates as a group of companies. LLC is the holding company based in Sri Lanka. We are in 31 countries in different businesses. Under LLC, we have LLC Advanced Technologies based in Australia. Under LLC Advanced Technologies, we have Ceylon Graphene Technologies. But as a new member, we have Graphenova. Graphenova is dedicated to fabricate plants to produce different types of carbonaceous materials, and especially graphene oxide and modifications, mission-specific graphene oxide derivatives. Next slide. So there's a third slide there. I can't see, so I'm continuing.
Yes.
Yeah. So currently, we have 4 major affiliations. We are currently putting up a pilot plant, small scale, 2 tons per year pilot plant in Khalifa University in Abu Dhabi. Parallelly, we have 2 dedicated laboratories. One is in Melbourne University Civil Engineering Laboratory. Other lab is in Adelaide University 2D Center, 2D Materials Center, led by Professor Losik Dusan. So both are the LOLC and Ceylon Graphene invested labs. What we do is we develop different types of carbonaceous materials, and we develop applications with our materials and fine-tune different materials for mission-specific and subject-specific applications. And we are a Manchester Geek member as well. So now, my philosophy and the concept of the company is, now we have been developing materials, sending samples to various manufacturers. Everclock, one of our sample users, we have given a lot of materials to most of the very serious graphene related product developers, application developers in the world. But at one point, we have realized that once we give samples, or once we use samples as a research company, once you are okay, or once you have proper data sets, once you are ready to go into the pilot or industrial level, you have no proper suppliers of large scale graphene materials. Imagine a situation, you go to Sigma Aldrich, you go to various other suppliers, buy a couple of grams of GEO or any other mission-specific materials developed by them, and you ask your scientists to run your application development. At one point, you are a success. So once you are a success, for you to roll it out, to roll out the program, you don't have a large-scale material manufacturer. So we have been facing this problem. We were listening, or we heard a lot of complaints coming from the industry because they didn't have a proper material supplier to buy the same material at the correct price, and the large scale material manufacturers was not available a couple of years ago. As a result, as a solution, we started producing our own plants. Now, if you are a industrial graphene user, you can research with our material, you can develop with our material, you can come up with your prototypes, test your prototype, fine tune it. At one point, when you're ready to go into the industry, to the market, we can offer you a plant to produce the same material you have been working with. So that is our idea. So we have three types of plants. The most important aspect of our plant is it's modular. Your team can run the plant. It will be 100% automated. We have in-plant quality control measures. We have different inline quality assurance systems to maintain your exact quality, which you want. We will be providing you the raw material, Sri Lankan vein graphite. We tune up the plant to work with your requirements, your particle sizes, your aspect ratios, your IDIG ratios, whatever it is. We fine tune it according to your needs, and we will be giving you the plant for you to run. That is the plan here. So the other scenario is our plants, we fine tune it, and we have reduced the carbon dioxide footprint by 40 to 45%. We have reduced the waste creation by 35-40%, and whatever the waste comes out from the plant, we have another plan to convert it into usable fertilizer materials. We have tested it, got all the approvals from different government and official sectors to convert this waste into sellable and usable, highly concentrated agriculture products. Then you can immediately increase the capacity by adding modules. It's a modular based scenario. Next slide, Terence. So we have started our business with three major sizes. One is 2 metric tons per annum. Second one, 5 metric tons per annum. The largest one is 10 metric tons per annum. So you can cut and chop and choose your requirement. If you want 10 tons plant, we propose 2 5 metric tons plant. Then you can nicely customize the plant to produce 2 types of material at the same time, or to reduce the size. If you really want 10 tons after another, let's say, couple of months, if your current requirement is only 2-3 tons, you can run half the capacity of the plant without any problems. And accordingly, we will be sending the raw material from our own mines, quality assured, carbon content assured, and the particle size assured. So the raw material will come, the major raw material, Sri Lankan vein graphite will come from us, from the same company, and plant will come to your industry, under your roof. You will be running a graphene manufacturing facility by your own staff. So there will be a couple of additional scenarios to be introduced now as an example. If your end industry is concrete or cementitious materials, we have fine-tuned some manufacturing techniques to suit only to concrete industry, because we have been doing this research and product developments and data collection from last 6-7 years. We have a dedicated team in Melbourne. They exactly came up with the proper data set, which graphene oxide should go into which application in cementitious materials. If it is for dry cement, we have different types of materials. If it is for concrete mixing in concrete applications, we have differently formulated, differently stabilized materials. You can produce all these target materials from that particular plant with simple additions. Some application demands extremely purified graphene oxides, some does not. Right? As an example, some of the cementitious material requirements are semi-washed, semi-processed materials. We have fine-tuned these materials into suit to these particular applications. At one point, you can cut down your application cost by focusing only towards the material which you want. As an example, I'll take a very simple example. If you really want to mix geo with your cement mortar, washing cycles of your graphene oxide will be reduced. You can cut down a couple of washing cycles to get the optimum performance in your cement mortar. So then you don't have to buy highly purified graphene oxide at a higher cost. Since you manufacture it in-house, you can define your manufacturing process according to the requirement you have exactly. That is why I use the word mission specific requirements. If you don't need very highly purified materials, you can cut down your purification process and use it. Then you obviously you cut down your production cost. So similarly, we have done a lot of work with specific applications in lead acid batteries, in plastic composites or polymer composites in that aspect. Likewise, we have fine-tuned which material we used in which area. So we can do some add-ons and we can simply reduce some parts of the plant according to your needs. So these are the rough pricing ideas for basic 3 plant sizes. 2 tons per year plant will be in the range of $1.85 million, 100% installed and run. The 5-ton plant is in the range of $3.2 billion, and the 10-ton plant is in the range of $5 million. So in this, in this price, you get the entire plant installed with the first year worth of raw materials needed, free of charge from our mines, according to your end product demands. So this is where we are. This is, Terence, go to the page number 10.
Okay. Main manufacturing line.
No, page number 10 is basically the 3D drawings of the small plant.
Okay.
Yeah. So this is the plant we have designed and now installing in Khalifa University. This is a modular plant, 2.5 tons per year. The beauty of this plant is this is a fully automated plant. It's a splitted plant where you can stop reactions at any point, and you can add different additional materials. You can run independent reactions to functionalize. You can cut down washing. You can add additional washing. You can add additional certification for ultra clean and ultra pure materials. Likewise, this is basically a modular and a research type of a plant, but we can produce 2 to 2.5 tons per year. So you can if you are an industrialist, if you are an industrial product manufacturer, if you are a graphene user for specific range of products, you don't need that much of a sophistication in your plant because you know what exactly you want. Here, this plant is basically to produce whatever the material needed by the researchers and to push their products or their prototypes into pilot scale manufacturing. So this is the size, this is the complexity of the plant. The only difference is when it comes to 2 to 2.5 ton plants, we are using glass reactors. Then you can see the color changes, you can see the reaction happening, everything. But when it comes to fully commercialized or fully industrial plant, we are not using glass reactors anymore. And the other beauty is with the new technology we have developed, with the new IP we have created, the complete reaction is less than 2.5 to 3 hours. So from graphite to graphite oxide to purified graphene oxide, the complete reaction will happen within 2.5 to 3 hours. Then you can run multiple cycles per day. So accordingly, when you cut down your cleaning cycle, when you cut down some of the steps of the process, your 2 tons plant will produce 3.5, 4 tons accordingly, because you cut down some of the steps of your complete process. So this is where we are now. For the first time,
Manju, sorry to interrupt. We have 1 minute.
Yeah, sure. So I'm finishing. Yeah. So for the first time, there's a company where you can go and buy a mission-specific manufacturer for graphene oxides, customized graphene oxides and any types of functionalized graphene oxides for your industrial needs. Thank you, Terence. This is where we are.
Thank you, Manju. And we'll make sure to include your contact information on the slides that we distribute for the audience, so they know how to get in touch with you and ask questions. I think your approach is quite interesting. Not only is it obviously suited for a company that maybe wants to produce for their own consumption, but this is also an opportunity for individuals or investors that maybe want to enter the graphene production space, is a way for them to acquire existing technology to do that.
For more information on market opportunities and to connect with experts, contact the Graphene Council at thegraphenecouncil.org.